So welcome to my channel and welcome to day 3 of the Maker Advent project. So I'm going to pull out box number 3 here. Okay, box number 3. Let's have a look what is in that box today. So box number 3 contents. You'll find another packet. Here we go, another packet, well packaged. So another breadboard. So this time it's a mini breadboard. So a mini breadboard. We've got 7 male-to-male jumper cables here. And we have 3 tactile buttons and 3 caps, but they've already got the caps on. So that saves me a job. Thank you very much. Today we'll be programming the buttons in your box as inputs for our code. Whilst we can easily use code to trigger our program to do things such as counting, components like buttons and switches allow us to physically interact with our project. Most buttons are very simple, just connecting a circuit together which then sends a signal to our Raspberry Pi Pico via the chosen GPIO pin. You could do the same by simply touching 2 wires together. But of course, buttons make this far more convenient and user-friendly. We're also going to be using the mini breadboard as a little control panel for our project, as we're going to make use of our LED circuit from yesterday. It's a handy part to have in your growing stash of bits, and it will come in handy for some of the other boxes too. Oh, and the button caps. They're just a nice little extra that make each click that little bit more satisfying. Clickety click click, clickety click. So now what we've got to do is we've got to construct this circuit. So, as always, first make sure your Pico is disconnected from your computer. Okay, so I just plugged it all in, so I'll just turn it all off and I'll just disconnect it. It is a bit stiff, but it does come out. Okay, so now grab the mini breadboard and pop each button into a few holes apart, making sure the legs sit either side of the little channel in the middle. Okay. So oh, they are actually like a certain way around. That's button number 1. Wow, this is tricky. Jeez. Well, they're in there. Not sure how well, but they're in there. Now we need to connect a 3.3 volt pin from the Pico to the top red lane on our main breadboard. pop a jumper wire into the 3v3 out pin on the Pico, pin number 36, then connect the other side to the top red lane. Okay, should I use a red wire here? Okay, so pin number 36 is 33, 34, 35, 36, and then to the red channel. Okay, so I've just done that there. Pin 36 to the red channel. Okay, it says to do it a little bit differently, so we're doing it over to the other side. I guess that makes sense. Okay, so we've put it from pin 36 all the way over to the other side. Okay, now we are going to hook up the rest of the pins. So we're doing the bottom right leg of each button to the positive channel. Like so. So we've got each one of those wires to the bottom right leg of each of those buttons, and they all go into that positive channel there. Lastly, we need to connect the other side of the buttons to the GPIO pins. Add a number 13, 8, and 3. Thirteen, 8, and 3. So that's physical pins 17, 11, and 5. So 1, 2, 3, 4, 5. Eight, 9, 10, 11, 11, and then lastly but not least, number 17. So that's 13, so 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we've done that. We've added them into pins 17, and now we've got them looking just like this. Looks nice. So activity 1, button test program. We'll first run a simple test program on one of the buttons. Each button has been wired to a GPIO pin. So we can set these as inputs to trigger some text to print when they're being pressed. We'll use a while loop so that the program keeps watching for the button press forever, with a new function, an if statement to determine what happens when the button is pressed. So if statements. If you've used Microsoft Excel or similar software previously, you'll have already guessed what if statements do. If statements allow us to give our code different outcomes depending on values, inputs, and many other things, such as if the first button is pressed, light the red LED. If the condition for this statement is met, our program will run the code inside the code block, which is indented underneath. Indentation is important again here. The while loop block is indented, but as the while loop contains an if statement, we indent yet again for the if statement block of code. Look at the example below to see this in action. If statements can be very powerful, and there are lots of different and advanced ways to use them. You'll use them for lots of making your own code. We'll start with a nice simple example. But first, let's explain something else in our code, pull downs. Our code below uses pull downs. You can see this at the end of each of the button setup sections as pin.pulldown. So why do we add this? When we use a button, we're sending 3.3 volts to the GPIO pin to set it high. However, we need to make sure the pin is low in the first place of our code, or it might not be able to detect a change, or it might trigger itself randomly. This is because GPIO pins with no pull down or pull up can be floating between 0 volts and 3.3 volts. Pulling down the pin to 0 volts ensures it's always low to start with. Sometimes this is achieved by using physical resistors in a circuit. However, some microcontrollers, such as our Pico, have this functionality built in, and we can simply enable them in our code. The code. So this initial simple code uses the first button. The code includes our usual imports and pin setup. Then starts a while loop. The while loop contains an if statement that looks for high signal on GPIO 13. If the button is pressed and a signal is sent to that pin, our code will print button 1 is pressed. We include a short delay in this loop to give your finger a chance to release the button to avoid the code triggering many times from a single press, known as debouncing. Values of 0.1 or 0.2 seconds usually work well. Copy the example over to Thonny and give it a go. What I'm going to do is I'm going to save what we've done for day 2. Complete. Okay. And then I won't feel bad for removing all of that. Oh, I need to plug in my Raspberry Pi. So let's plug it back in the Raspberry Pi Pico with our USB. Okay, I've plugged in the Raspberry Pi and I've run the script, and then we're just going to press button 1, button 1, button 1, button 1, button 1. So as I'm pressing it, it's adding down here an output to say it's been done. If I push any of the buttons, that doesn't work. So that's good. That's working well. So activity 2, multiple button inputs. Let's add our other buttons into the code and change our if statement to make it watch for any of them being pressed. To do this, we add setup lines for the other buttons, then add additional if statements below the original one. Our code will simply check each button condition in order. If one of the conditions is met, if a button is pressed, it will run the code for that button and will continue the loop. So let's copy that. Let's replace everything there and paste. Right, let's run it. And then we can go button 1, button 2, button 3, button 1, button 2, button 3. And I'm getting that output there. So that's all working as it's described. So activity 3, multiple button inputs with elif and else. What if we wanted to do something more advanced with our buttons? Maybe we want to ignore buttons 2 and 3 if button 1 is pressed. Do we want something else to happen if none of the buttons are pressed? Perhaps we want something to happen if we hold 2 buttons down at the same time. We can do many of these things and more by using our if statement and additional statements elif and else. Let's explain how they work before we try them. So the elif statement is short for else if. If your first if statement isn't true, your code will then check each elif statement in order to see if any of those are true. If one of the elif statements triggers, it will run the code block for that statement only and then stop checking the others in the loop, unlike regular if statements which keep checking each one after each other regardless of what happens. In the example below, we use if then elif to tell our code to check if button 1 is being pressed, and if not, check button 2, and if button 2 isn't being pressed, then to check button 3. So there should always be an initial if statement first. So let's copy all this code and again replace what we have in the window. And then we'll run it. The else statement says if none of the statements above have their conditions met, do this instead. It can be useful if you want something to always happen when none of the above if elif statements are being met. Here's a short example using just 2 buttons you can try where we always print no button presses if none of the buttons are being pressed. The commentary shows you where this else statement is being used. Okay, so let's copy that, paste it in our project and run it. Okay, so no buttons are being pressed at the moment, so it's printing that out in the shell. And if I'm pressing button 2, if button 1, and button 3 has stopped working. Oh no, the button 3 isn't included in this. So it just picks up. Excellent. Now that we know what elif and else do, let's put them to work whilst adding our LEDs back into our program. The code below first checks if we've held buttons 1 and 2 together. It does this by using an if statement with and between 2 conditions, asking for both of these to be met at the same time. If the buttons are both held down, the green light will light. We then use an elif statement to check if button 1 is being pressed on its own. If so, the amber light will light. Then we use the else statement to light the red light LED and turn off all the others. If nothing is being pressed, button 3 isn't being used for this example. All of this is in a while true loop to make it run forever. So we copy all this code, we paste it in here, and we run it. Okay, so the red LED is on, and if I push button 1, then the amber light is lighting, and if I push button 2, nothing happens. If I push both together, then the green one comes on. Fantastic. Great job. So activity 4, this button or that button. Another trick we can use with buttons and if statements is to use or between conditions to check if one of our buttons is being pressed. Make sure them all trigger the same result. We've added an example below which looks for either button 1 or 2 being pressed. Once you've tried it, why not have a go at adding button 3 back into the code and then make all 3 buttons trigger the LED. Okay, so let's copy this code to our project again, paste. We're going to run it. Okay, so we're running. Okay, so we're running this. So button 1, button 1. If we press it, it stays on for a little bit and then goes off. But nothing else. So if I press button 2, this green light will come on. So it's just if either one of these buttons is being pressed, it will turn that light on. Okay, so another trick we can use with buttons and if statements is to use or between conditions to check if one of our buttons is being pressed, but make them all trigger the same result. We've added an example below which looks for either button 1 or 2 being pressed. Once you've tried it, why not try adding button 3 back into the code and then make all 3 buttons trigger the LED. Okay, so if we're looking at the code as it is now, when buttons 1 and 2 are being pressed, when buttons 1 and 2 are being pressed here, then print button 1 or 2 is pressed, light the green LED, and after 2 seconds turn off the green LED. Then we want to add in button 3 equals pin and then thirteen 8 13 8 and 3. Okay, 13 3 and then pin dot in comma pin dot pull underscore down. Remember to maintain the capitals or the correct case. Okay, so we've added button 3 into this, so when so it recognizes that button, and then we want to copy that and then paste button 3. Button 1, then let's change the commentary to say button 1, 2, or 3 pressed. Okay, so let's run this script. And then I can say, there we go, that's button 1, that's button 2, and that's button 3. So button 1, button 2, button 3. Excellent. So I'm just saving these along the way, just in case I ever need to look back on any of the code that I've previously put through here. And I've put complete, I've saved a complete version of it so I know that it works. Okay, so activity number 5, toggling with buttons. Another handy feature we can use with GPIO pins is toggle. As you might have guessed, this toggles a pin status from high to low to high, and so on. The example below is mostly the same, but uses button 1 to toggle the red LED on and off. Once you've tried the code below, why not try adding the other buttons and LEDs back in, toggling each of them. So let's copy the code to our project. Okay. And let's run this. Now this said that it's only written for button 1 to toggle the red LED on and off. So if I push button 1 now, it turns the red LED on and off. But there's a delay in there. That's why I'm pressing it too many times. Cut off. Excellent. So let's try adding the other buttons and LEDs back in, toggling each of them. Okay. So button 2, I can nick that code from there, copy and paste. And then I could do button 3 as well. Button 3, and that's pin 3. And then we need to add in our LEDs. Which are these ones. Okay. So, while true, loop forever, time sleep 0.5. If button 1 value is pressed, then toggle the red on and off. So if I copy this, paste. So if button 2 and button 3, we'll do amber, amber, amber. Oh, sorry, I changed that. That should be red, amber, green, changing the commentary along the way. Amber. Button 2 pressed. Button 3 pressed. Okay, let's give that a go, shall we? So, I'll run the script. Okay. So, if button 1 is pressed, the red LED lights. If I press it again, it goes off. If I press button 2 now, then the yellow, the amber LED comes on. If I press it again, it goes off. And if I press button 3, then the green LED comes on, and if I press it again, then it goes off. Fantastic. So, day 3 complete. Great job, makers. You've now got the skills to use physical inputs with MicroPython and can code if statements in all sorts of interesting new ways. Today, you have learned how to create a circuit with physical inputs, how to code physical inputs with MicroPython, what if statements are and how to use them, how to use elif and else within if statements, how to use and or within if statement conditions, combined physical inputs with physical outputs. As always, please do not disassemble this circuit until tomorrow, where we'll explore the next fun component. See you then. Excellent. So that's it from me. Thank you very much for watching, and we'll see you here again tomorrow for day number 4. Thank you. Bye-bye.